Hey everyone, and a huge welcome to the channel. To all of you watching right now, wherever you are in the world, I'm sending my very best wishes your way. I truly hope you and your families are feeling fantastic, staying strong, and in the best of health. Let's explore something amazing together today. When we think of the world's great mountain ranges, our minds usually travel to places like the mighty Himalayas, with Mount Everest scraping the sky, or the long, rugged spine of the Andes running down the coast of South America. These are the iconic peaks we see in photographs, the ones climbers dream of conquering. They feel immense, permanent, and utterly dominant on our planet. But what if I told you that these legendary landforms are merely the tips of the iceberg, and that the most extensive and massive mountain range on Earth is actually hidden entirely from our everyday view? It lies deep beneath the waves of the ocean, a vast, mysterious, and mostly unexplored world that makes the mountains on land seem almost small by comparison. This is the story of the underwater mountain ranges that are longer than anything we have on the continents. This incredible hidden range is called the Mid-Ocean Ridge System. Imagine a single, continuous chain of mountains that snakes its way around the entire globe like the seams on a baseball. It stretches for an almost unimaginable 60,000 kilometers. That's a 60 followed by 3 zeros. To put that distance into perspective, if you could somehow pick up the entire circumference of the Earth at the equator, it would only measure about 40,000 kilometers. So this underwater mountain range is half as long again as the entire planet is around. The longest mountain range on land, the Andes, is about 7,000 kilometers long, which is incredibly impressive, but it is utterly dwarfed by the sheer scale of the Mid-Ocean Ridge. This submerged behemoth winds through every major ocean, a mostly hidden backbone for the world's oceans. But why is it there? How did such a massive geological feature form? The answer lies deep below the seafloor, in the slow, churning motion of the Earth itself. Our planet's outer shell, called the lithosphere, isn't one solid piece. It's broken up into gigantic tectonic plates that fit together like a jigsaw puzzle. These plates are constantly, slowly moving. The Mid-Ocean Ridge is the place where two plates are being pulled apart from each other. As the plates separate, it creates a massive gap, a tear in the Earth's crust. This allows material from the hot, soft layer beneath the crust, called the mantle, to well up and fill the space. This material is molten rock or magma. When this magma meets the incredibly cold water of the deep ocean, it instantly cools and solidifies, forming new oceanic crust. So, right at the center of this underwater mountain range, new seafloor is being born every single day. It's a factory for the planet's surface, constantly adding new material and pushing the older crust outward, away from the ridge. This process doesn't create a single, sharp peak like a mountain on land. Instead, the ridge has a very distinct shape. At its very center is a deep valley called a rift valley. This is the actual fissure, the crack where the plates are diverging. On either side of this valley are towering peaks and cliffs, creating a dramatic, rugged landscape that runs for thousands of kilometers in both directions. The entire ridge system isn't a flat, smooth wall either. It's complex and jagged, cut through with countless transform faults and fracture zones that give it a twisted, broken appearance. The height of these mountains is also staggering. While their peaks are still thousands of meters below the ocean surface, they often rise 2,000 to 3,000 meters from the abyssal plain on either side. If they were located on land, they would easily rank among the world's tallest mountain ranges. The difference is simply that their base is already so deep underwater. Because this entire world is submerged under immense pressure and total darkness, exploring it has been one of the greatest challenges in human history. We couldn't even confirm its full existence until the second half of the 20th century. It was through the use of sonar, a technology that uses sound waves to map the seafloor, that scientists began to piece together the true scope of this hidden range. Later, deep-diving submersibles like Alvin allowed humans to personally witness this alien landscape. The views are unlike anything on the surface. Instead of sunlight, the darkness is broken by the eerie glow of incredible life forms. This is because the process of creating new crust isn't just about lava. Seawater seeps down into the hot, fractured rock, gets superheated, and dissolves minerals from the magma. It then jets back out of the seafloor through hydrothermal vents, which look like underwater chimneys. These vents spew out water rich in minerals and superhot, sometimes reaching over 400 degrees Celsius, but not boiling because of the extreme pressure. This mineral-rich water supports one of the most fascinating ecosystems on Earth, completely independent of the sun. Bacteria use a process called chemosynthesis to convert the chemicals from the vents, like hydrogen sulfide, into energy. These bacteria form the base of a food web that includes gigantic tube worms, strange white crabs, unique clams, and a host of other organisms found nowhere else on the planet. These deep-sea oases are like islands of life in a vast desert, all thanks to the geological activity of the mid-ocean ridge. So, these mountains aren't just barren rock. They're alive, supporting strange and wonderful communities that have rewritten our understanding of where and how life can thrive. The influence of this massive underwater range extends far beyond its own peaks and valleys. It plays a critical role in shaping the entire ocean. The topography of the ridge influences deep-sea currents, which are like the conveyor belts of the ocean, moving heat, nutrients, and oxygen around the planet. This, in turn, affects global climate patterns and the health of fisheries worldwide. Furthermore, the constant creation of new seafloor at the ridges and the destruction of old crust elsewhere, in a process called subduction, means that the entire ocean floor is constantly being recycled. The oldest ocean floor is only about 200 million years old, which is very young compared to the billion-year-old rocks found on the continents. So, the next time you look at a map of the world or stand on a beach looking out at the ocean, remember what lies beneath. The deep ocean is not a flat, muddy, empty plain. It is home to the most magnificent and longest mountain range on our planet, a dynamic, ever-changing landscape where the Earth itself is being reshaped. It's a place of fire and ice, where volcanic rock meets freezing water, and where life exists in the most unexpected ways. It reminds us that there are still vast frontiers of our own world waiting to be discovered, holding secrets that continue to inspire awe and wonder. Our planet is so much more than what we see on the surface, and its greatest wonders are often hidden in the deep, waiting for us to explore.